right, so here's the review for the semester exam for the end of the year, and you're going to, all these questions will be similar to the ones on your final. All right, so we have number 1 here. It says when 4x squared plus 3x minus 5 is subtracted from negative 2x cubed minus 5x minus 12, what is the difference? So the key word here is difference, and we're curious about which one's being subtracted from. So we're going to take the second one, negative 2x cubed minus 5x minus 12, and I'm actually going to leave a space for the x squared because we don't have an x squared in this one. So I'm going to put 0x squared minus 5x minus 12. And then I'm going to subtract in parentheses 4x squared. So I'm putting that in the wrong spot. 4x squared plus 3x minus 5. And then all we do is go straight down. So negative 2x cubed, there's nothing underneath it, so we keep negative 2x cubed. 0 minus 4x squared is negative 4x squared. Negative 5 minus 3 is going to be negative 8x, and then negative 12 minus negative 5 is going to be negative 7. And that is your final answer. Easy as that. So the next one, number 2, is determine the expression of the area of the triangle below. Note that area for a triangle is 1/2 base times height. So we're going to have area equals 1/2, and then it's going to be our base, which is 1/2 x cubed minus 4y to the 6th, and our height is going to be 2/3 x cubed plus 4y squared. Okay, so we're going to go ahead and I'm going to rewrite this. I'm just going to go ahead and distribute this 1/2 to all of it and put it underneath divided by 2. So this is a binomial. We're going to multiply it the way we do normally. So we're going to take our first term times our first term. So we have 1/2 times 2/3, and that gives me 2/6 x, and then we have x cubed times x cubed, so that's x to the 6th. And then I'm going to have 1/2 x cubed times 4y squared, so that's going to give me plus 2x cubed y squared. And then we have negative 4y to the 6th times 2/3x cubed. So that's going to give me minus 8/3 x cubed y to the 6th. And then we are going to have our last one, which is negative 4y to the 6th times 4y squared. And that's going to give me negative 16y to the 8th. And remember, when you multiply exponents, you add them together. And then we're going to divide everything by 2. So we have 2/6. That's the same thing as 1/3. And when we divide things by 2, or divide a fraction by 2, it's like multiplying by its reciprocal. So if we have 1/3 divided by 2, we're going to end up with 1/6. And that's going to be x to the 6th. 2/2 is just 1, so we're going to have x cubed y squared. 8/3 divided by 2 is going to give me, let's see, 8/3 times 1/2 is equal to 8/6. 8/6 is 4/3. So 4/3 x cubed y to the 6th. And then 16 divided by 2 is 8, and then y to the 8th. So the answer is a grand total of 1/6 x to the 6th plus x cubed y squared minus 4/3 x cubed y to the 6th minus 8 y to the 8th. A little bit tedious, but it is what it is. All right, so the next one we have is factoring. We want to determine the greatest common factor of 27x cubed y squared and 45x to the 4th y. So the easy thing is to go ahead is the variables and exponents. We just take the variable with the lowest of the exponents. So in this case, we're going to have our x cubed and our y. Those are going to be part of our answer, x cubed y. So we need to figure out what our factors of 27 and 45 are. So we're going to factor 27. It's 1 in 27. 3, and 9, and that's it. 45 is 1 and 45, 3 and 15, 5 and 9. And the biggest number that's in both lists is 9. So our answer is 9x cubed y. The next one we have is 18x squared minus 50. Now, we want to factor this completely. We notice that these are both even. Neither of them are perfect squares, but if we divide them both by 2, and we'll get 9x squared minus 25. Those are both perfect squares, and remember, when we have a difference of squares, we're just going to take the square root of the first one, so we have 3x, and the square root of the second one, and add them. And then our second term will be the square root of the first minus the square root of the second. And that's all there is to that. All right, number 3 says write an expression to determine the length of the side of the square below. So this is a square. We're taking the square root of 9x squared minus 12x plus 4. So to do that, we're going to factor 9 times 4 is 36. And so we know we're going to need the ones that are going to give us negative 12. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And we're going to use 6 and 6. So what we're going to have is 9x squared minus 6x minus 6x plus 4. And I'm factoring by grouping because it's the easiest one to do. If you want to use the box method, that's fine. But I like to factor by grouping, and so do most of you. So I'm going to go ahead and do that. So we're going to group them. My common factor between 9x squared and negative 6x is going to be 3x, and that leaves me with 3x minus 2. And then here we have 6x plus 4. Common factor is going to be negative 2. And that leaves me again with 3x minus 2. One thing you can do is think of, with the second term, how do I get it to match this one? And so we're going to have 3x minus 2 quantity squared, because both of my factors are 3x minus 2. And you can see that when we look here. So what's in the parentheses is one term. And then again, what's outside the parentheses is the other term. So we have 3x minus 2 and 3x minus 2. Okay, so on this next one, it just wants us to factor using very specific techniques. So for A, it says greatest common factor. So we know these can both be divided by 5. They don't both have an x, but they both have a y. And we're left with x minus 5y. Okay, that's all there is to that one. Perfect square trinomials. It's pretty simple. We're just going to take half of b. So it's x plus 1 squared. Same thing for this one. Comes x minus 1 squared. Again, this one's grouping. We're factoring with 4 plus terms, so we're just going to break it off into 2 pieces. And I have 4x cubed and 20x squared. Common factor is 4x squared. And then I'm going to be left with x plus 5. And then I have 7x plus 35. I'm going to go ahead and take out the plus 7. And then I'm left again with x plus 5. And so my factors are 4x squared plus 7 times x plus 5. We have this one right here, 25x cubed plus 5x squared plus 30x plus 6. Again, we're going to break it into 2 chunks. Common factor between 25x cubed and 5x squared is going to be 5x squared. And that leaves us with 5x plus 1. Common factor from 30x and 6 is 6. And again, that leaves us with 5x plus 1. And so our factors are 5x squared plus 6 and 5x plus 1. Last one, 35x plus 28xy, 20y plus 25. We have 35x and 28xy, so that's 7x. And that's going to leave me with 5 plus 4y. And then we're going to take out the common factor from 20y and 25, and that's going to be 5. And that gives me 4y plus 5. But remember, addition is commutative, so it doesn't matter what order we put them in. So 5 plus 4y and 4y plus 5 are exactly the same thing. So we're going to have 7x plus 5 and 4y plus 5. And those are our two factors. So for D here, we have difference of squares. Again, that's simple. I'm sorry I didn't have that on the screen. We have the square root of the first, 2x, plus the square root of the second, which is 9, times square root of the first, minus the square root of the second. Easy peasy lemon squeezy. Again, same thing here, square root of the first, x squared, plus square root of the second, and square root of the first minus square root of the second gives us x squared plus 9 and x squared minus 9. Now, x squared minus 9 is still the difference of squares. So we're not going to do anything to x squared plus 9. However, we are going to factor x squared minus 9 to x plus 3 and x minus 3. Again, square root of the first plus the square root of the second, and square root of the first minus the square root of the second. Finally, we have 81x to the fourth minus 625. And so we're going to start with square root of the first, which is 9x squared. And then we're going to do the square root of the second. All right, so plus 25. And then same thing, square root of the first, 9x squared minus square root of the second, which is 25. And again, we have a difference of squares as our second term. So we're going to go ahead and have 9x squared plus 25 stay the same. And then again, square root of the first, 3x, plus 5, which is the square root of the second, square root of the first minus square root of the second. That's all we have to do with the difference of squares. All right, moving on. We have rational operations. It wants us to perform the indicated operation. So the first one says 3x minus 5 over 2x squared plus x plus 2 over 6x. So on this one, I'm going to do it on a separate sheet of paper so that I can show you all of the steps. So let's see. So we have 3x minus 5 over 2x squared. And we need to have a common factor with x plus 2 over 6x. So what we need to do is break down our denominators and find common factors so we can figure out how to make them the same denominator. So we're going to leave the top the same for now. And I'm going to break down the denominator to 2x squared to 2 times x times x. Then we're going to have x plus 2, and that's going to be 2 times 3 times x. And what we're going to do is we are going to look here and here. We have a 2 in both, so we don't need to multiply the 2 in. We have an x in both. So each of these needs what the other one has. So I need to multiply the 2x squared by 3, and I need to multiply the 6x by x. So let's go ahead and do that. So I'm going to have my 3x minus 5 over 2x squared, and then I need to keep it equal, but I still need 3. So I'm going to multiply it by 3 over 3, because 3 over 3 is 1. And then I'm going to have x plus 2 over 6x, and we need an x for this one, so we're going to have x over x. So that's going to give me 9x minus 15 over 6x squared plus x squared plus 2x over 6x squared. And now we can do the indicated operation, which is simply to add them together. So we only have one x squared, so we're going to have x squared. We have 9x and 2x, that gives me 11x, and we have minus 15. And all of that is going to be over 6x squared. There are no common factors, so that is our simplest version. Now for number 2, we're multiplying rational expressions. That's much simpler. We are going to factor these a bit, so let's go ahead and break this one down. We have 4r minus 12, so we're going to take out the 4 and we're left with r minus 3. And that's going to be over r minus 2. And we still have r minus 3 on the other one. R squared minus 4, again, that's a difference of squares. So square of the first plus the square of the second times square of the first minus square of the second. And then what we're going to do is we're going to eliminate anything on the top that matches on the bottom. So the r minus 3 and the r minus 3 cancel each other out. And the r minus 2 and the r minus 2 cancel each other out. So I'm left with 4 times r plus 2, or 4r, that was an x, 4r plus 8. Finally, on this page, we have 2x over 3x minus 12 divided by x squared minus 4 over x squared minus 6x plus 8. Remember, whenever you're dividing by a fraction, you are multiplying by its reciprocal. So what we're going to do is we're going to change this to multiplication, and we're going to flip this rational expression. So the first one stays the same, so it's keep, change, flip. And we're going to multiply by the reciprocal. So I'm going to go ahead and factor x squared minus 4 to x plus 2 and x minus 2. And I'm going to factor x squared minus 6x plus 8. And the way I'm going to get that is going to be, let's see, 4 and 2. All right, so it's going to be x minus 4, x minus 2. And again, anything on the top that matches the bottom gets it crossed out. So then we're left with 2 times x minus 4, and that's going to be over 3x minus 2 times x plus 2. And I'm sure you've noticed that we need to multiply this out, so we're not going to leave it like this. We're going to go ahead and take it to its conclusion. So we're going to have 2x minus 8 because we distribute this 2. And then we're going to have 3x squared plus 6x and then minus 2x. That's going to give me 4x. And then negative 2 times positive 2 is negative 4. And that is the final answer for that problem. So that's pages 1 and 2 of your review. I'm going to come back in just a few minutes and we're going to do pages 3 and on.